Hello, my name is Levi Simster,
and Kaiser Williams.
and our project focuses on developing a database to train facial emotion detection. Our phenomenal mentors are Roshan and Ganesh.
COVID-19 has made it difficult to have in-person theater performances, and video software like Zoom have been utilized for live production. However, the audience performance feedback loop, which is the dynamic exchange of emotional information from the audience to the performer, such as clapping and booing, is not viable in a virtual setting, and the presenter cannot get insight on their performance. A solution to this is detecting the emotions of the audience members by analyzing their facial movements and providing that data to the presenter in real time. This consists of first detecting a human face in the video feed and then analyzing the facial landmark movements using a convolutional neural network. However, it is important to keep in mind the lag between the audience reaction and the presenter receiving the feedback data.
Our goal is to build an interactive subject-observer software to create a database which may be used to train a machine learning model in order to determine whether a relationship exists between face mesh and face and body emotion states. The subject-observer interface will be an integrated data collection browser environment where the subject will be shown a video to react to, whilst their live webcam feed is analyzed by the observer. The observer will identify what emotions and emotional expressions they perceive from the facial reactions of the subject with a set of buttons. Simultaneously, face mesh landmark movement data collection will occur in the background. The frameworks we used for the face detection and the face mesh were MediaPipe's ML library and TensorFlow.js. The MediaPipe framework comes preloaded with JavaScript objects that determine face detection and facial landmarks based on the webcam feed. This task involves storing this object across multiple frames in concise data packets. A packet consists of 10 sets of face mesh data with 468 points and 3 dimensions each, along with a single timestamp depicting the end of data collection for that packet. An array buffer storage solution is necessary because storing one packet as a string would have used 538,260 bytes because UTF-16 encodes 2 bytes per each character. Using the float32 array buffer solution, we only use 56,168 bytes because it uses 4 bytes per every float32 or decimal number in the array buffer per packet. Not to mention that this is before truncation of the decimals in each packet in order to reduce precision by a slight amount, but increase computational efficiency. By doing this, we can expect further improvements around the magnitude of 1/2 the current consumed bitrate. After these improvements, the buffer bitrate will be 5% of the string representation bitrate.
Next, we developed a simple browser interface where the subject's webcam feed will be displayed on the observer screen. Below is a set of 11 buttons corresponding to 11 emotions and emotional expressions, which the observer will press when they perceive a certain emotion on the subject's face. This data will be initially stored in a JSON object as an emotional timestamp pair. In the background, the emotions are given a key of 1 to 11 to easily convert this to binary later on. Once the observation is complete and the finish button is pressed, this JSON object will be stored into an array buffer as binary to save space, similar to task 1. However, JavaScript prevents editing and saving binary data as bin files to prevent malware installation, so we further convert this array buffer into an array of ASCII codes. Lastly, we are in development of an integrated environment which will make the webcam feed of the subject appear on the observer screen and allow both task 1 and task 2 to occur simultaneously. This involves combining the data entries of both tasks during the collection session to one single file. The aggregated data across many different sessions will be added to a data set which may be used to train a machine learning model.
In the future, we plan to find a way to combine the 2 data sets and store it in a single file. We then would like to build our dataset using different subjects and observers and eventually create a website using an API called WebRTC for people to upload their own data. This dataset can then be used to train a neural network to determine if mathematical correlations exist between face mesh and reactionary data. If successful, this project can be utilized to enhance the precision of machine learning algorithms and other neural networks in regards to facial landmark detection. Thank you so much for your time, and our GitHub repository will be posted in the chat.